So, crazy warm-up today. I'm not yelling at you. Sometimes when you see exclamation marks like in text, it means like they're yelling or it's like, ah, right? But anyways, yeah, the numbers are just really mad. No, you've never seen this before. Oh, Quan knows what it's called. Have you ever heard of what Quan just said? These are called factorials. They're called factorials. Let's talk about what a factorial is, and then today in the lesson you'll find out why people use factorials. Okay? So, a factorial is when you take a number, an integer, and you multiply it by the descending integers all the way to 1. So 5 factorial is 5 times 4 times 3 times 2 times 1. The 1 is, of course, unnecessary, but it is part of the definition of a factorial. So yeah, this factorial, it is actually a mathematical operation. Now, do you think that you always have to enter it in your calculator like that? Like if I said to do 20 factorial, which would be a huge number, by the way, would you have to go to your calculator and do 20 times 19 times 18 times 17? No, there has to be a way, right? So, did you look around in your calculator? Go to the Math menu. Click on Math. And then look at the one that says Probability. The factorial button. So if you press 5, and you go to Math, and you go to PRB, Probability, then you will see the factorial button. And then you press Enter, and it does all the work for you. So it's important, yeah, press Math, then go left, then press 4. Good. It's important that you know how a factorial works, but yes, you can let your calculator do the grunt work. But you still need to know what a factorial is and how it works, okay? So, if we do number 2, if we were doing that by hand, which I want you to do some of these by hand because I want you to see how they cancel, then number 2 is 4 times 3 times 2 times 1 over 3 times 2 times 1. So what's cool about 4 factorial divided by 3 factorial is that cancel, cancel, cancel. And the answer is 4. Or you could have done it in your calculator, but you need to know how these work. Do you really need the 1? It's just one of those things, it's like it's technically there. So no, when you multiply something by 1, you get itself, but it's part of the definition of a factorial. Number 3, and this will show up later in the lesson where this comes from, by the way. We're foreshadowing. Ooh, that's like an English term, isn't it? 6, 5, 4, 3, 2, 1, 2, oops, sorry, 2 times 1, 3 times 2 times 1. So this one's a little bit different. You can do this, 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 but then what it comes down to is it comes down to 6 times 5 times 4 over 2. And like I said, why do we care? Why do we need this? We absolutely will use this in our probability lesson today. All right? What's the final answer to number 3? Good, 60. Okay, let's move on right into the lesson because we don't have to check any homework, which is awesome. Have you ever been to Small Cakes? One of you gave me Small Cakes at the end of first semester. Thank you. Delicious. So, if you walked into Small Cakes and these were the options that they had, because every day they have different options. They feature different cupcakes. Anyways, if you had 3 cake choices, 5 icing choices, and 5 topping choices, how many different combinations could you make? How many different cupcake combos would there be? So how do we do this? Good, Avi, good. So this is actually called the fundamental counting principle, but it's good to know what it's called. You have 3 cake options, 5 icing options, and 5 topping options. So believe it or not, it is that easy. 3 times 5 times 5. You multiply the different number of options in each category. Now, if you could put 3 different toppings on it, now that would change it entirely, and we're not going to go there today. So, oh, Anna wants to go there for her meetup. Anyways, so how many combinations would there be? What's the answer to this one? 75. Very good. 75 different combos of cupcakes. So, like I said, that was the fundamental counting principle. So try it on this yogurt parfait one. Pretend you're going to Orange Leaf, or what are some other yogurt places by y'all? Yogurt Cup, Orange Leaf. There's so many different ones. TCBY, Tutti Frutti, oh my gosh. Menchie's, they make a lot of money. Kroger doesn't have frozen yogurt parfaits where you can put toppings on it. Yogurt Yo, oh my gosh. So this is super easy, right? 2 times 5 times 3. 30 different parfait choices from your favorite local frozen yogurt place. Okay. Let's step it up a little bit. You're asked to make a password for a website. It must have 5 letters followed by 1 number. How many possibilities are there? No, there's not an infinite number of possibilities. Actually, there's a finite number of possibilities, and we're going to find out how many. It's okay. Good question. Good. You're thinking. That's all I want. So here's how I look at it. You might look at it in a different way. But how many how many characters are going to be in this password? There's going to be 6 characters, right? Because 5 letters. 1, 2, 3, 4, 5 letters and 1 number. So this is letter, 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 followed by a number. Let's take it, there you go, Abby, good. Let's take it 1 number at a time, 1 character at a time. How many letters are there in the alphabet? So you have 26 options for your first letter. Did it say anything about how we can't repeat letters? Could I put the same letter 5 times? Why not? Absolutely you could. So in this slot, you have 26 choices, 26 choices, 26 choices, 26 choices. What about for the number slot? How many choices? There's actually 10. Be careful. You just think 1 through 9. Okay, I have 9 choices, but you're right. 0 is a number. Don't leave him out. He's totally a number. 0 counts. So 10 slots here. So it ends up being 26 to the 5th. Times 10. The answer was a really large number, right? I mean, there are tons and tons of combinations if you are going to have a 6-digit password, and you can choose pretty much anything you want. All right. Oh, here just for fun, I know this is old, 2012. Worst passwords of 2012. Password. 1, 2, 3, 4, 5, 6. ABC 1, 2, 3. QWERTY, y'all know what that is, right? The top letters across your keyboard. Monkey. Let me in. Dragon. 1, 1, 1, 1, 1. Baseball. Who knows? Okay. Now let's talk about permutations versus combinations. So there's different ways that we can categorize things depending on what we want the result to be. If you are looking at license plates, for example, the order matters. The order of the letters or numbers absolutely matters. That license plate and this license plate have the same characters. Those have the same characters. But are those the same license plate numbers? No, because the order would matter in a license plate. So with a permutation, the order matters. Now, in a combination, let's say I choose marbles from a bag and I get a red marble and a purple marble. Then I draw and I get a purple and then a red. Either way, I have a purple and a red in my hand. It doesn't matter which one left the bag first. The result is the same. I got a red and a purple. So in a combination, the order does not matter. Make sense? The 2 categories? Good? So, you have 3 objects. What do you want them to be? Let's give them a name so it's not like so hypothetical. Pizza. Okay. You have pepperoni, cheese, and veggie. Let's just be easy. Oh, my daughter's names. Oh, that was sweet. Let's do that one. Okay. Hallie, Annabelle, Caroline. Thanks, Bee. We'll do pizza next time. Okay, so if order matters, how could we arrange them? If we were lining them up and the order mattered, then we could do what? Hallie, Annabelle, Caroline. We could do Hallie, Caroline, Annabelle. We could do Annabelle, Hallie, Caroline. Annabelle, Caroline, Hallie. And then I'm running out of room. Caroline, Annabelle, Hallie, Caroline, Hallie, Annabelle. How many are there if order matters? Good! There are 6 ways to arrange them. 6 ways to arrange them. What about if order doesn't matter? Yeah. It's just one way. I mean, if the order doesn't matter, you just put their names there. I chose those 3, and the order doesn't matter. Why are you doing so many exclamation marks? Okay, so just to let you know, this is a permutation, this is a combination. There's always going to be way more permutations for a given set than there is going to be combinations for a given set. Okay? You want to select and order 3 people out of a group of 7. How many permutations are there? So that means out of this group of 7, the order matters. Let's say that it's 3 people, so you're giving them a gold, silver, and a bronze medal. So if someone gets the gold and someone gets the silver, it's different than if those are switched, right? If the other person got the gold and the other person got the silver. The order would matter because you're actually giving them medals. The color of the medals matters. So, how would we figure that one out? There's 3 different ways we could figure it out. Let me show you one of the ways. Okay, let's say this is gold, silver, bronze. Let's say I'm giving the gold medal first. It's a group of 7. How many choices do I have to give the gold medal to? 7. Now I'm going to give silver. Someone already got the gold. You can't get more than 1 medal. So how many choices do I have for silver? Yeah, you get the idea. And then bronze. So it's 7 times 6 times 5. Do we care about the other 4 people? No, I'm sorry. But you don't get a medal. So therefore, you're not part of our equation. And so the answer is 210. Now, no, they didn't win because they lost. Yes, that's usually how it works. Now, could we write this as an actual equation using factorials? We can absolutely write this as an equation using factorials. My numerator would be 7 factorial because there's 7 different people in my group. What would the denominator be? The denominator would be the losers. It'd be the people that don't get a medal. So the denominator would be 4 factorial. Do you agree that this equals this? Because in 7 factorial, 4 factorial, what's going to cancel? 4, 3, 2, 1. What's going to be left? 7 times 6 times 5. Does that make sense how I can turn this problem into a factorial equation? I can't tell if people are excited or if they're just using factorial. So, I need you to write this down in your notes. We are receiving 2 formulas today. This is the first formula, and unfortunately, it's not on your formula chart. So I'm giving you time to write this down in your notes, and then we'll talk about it, because it kind of looks intimidating, but it's not so bad. So how does this work in the problem that we just did? Well, we had 7 people. It was a permutation because order mattered. And 3 of them got medals. So it was like 7, permutation, 3. So how would this have looked in here? Well, this says n factorial. That would have been 7 factorial over n minus r factorial. 7 minus 3 factorial. Well, 7 minus 3 is 4, right? Those are the ones, sorry, we didn't care about. So this is 7 factorial over 4 factorial, which is exactly what we had on the slide before. So that's how this formula works. It would work for any time you're ever doing a permutation. It's nice to have a formula so you don't have to rethink the problem every single time. We already did that, okay? Here, I'm just going to throw at you, here's the number of combinations, the formula for combinations. Go ahead and write it down. I'll talk a little bit about the formula, and then we'll just dive into some examples. Compare and contrast the combination formula with the permutation formula. There's only one difference, right? You see the difference? Error 404, difference not found. Oh, man. So, what that R factorial does is that eliminates all the duplicates. That eliminates me saying red, blue is different from blue, red. If the order doesn't matter, red, blue, and blue, red can't each count as a separate one. You need to eliminate that difference because red, blue is the same as blue, red. And so that's what that R factorial does. It divides out that difference so that we're not worrying about the order. That's what the R factorial does. Let's go, guys. Let's solve some problems. How many ways can a student council select a president, vice president, secretary, and treasurer from a group of 6 candidates? So 6 people are running for office, and there's 4 slots. What you always start off by doing is asking yourself, is this a permutation or is it a combination? Does the order matter? Does Graham being president, is that different from V being president? It's absolutely different. So because you're assigning them titles, because they're getting names, order matters. Okay? So I'm going to show you 3 different ways to solve this because a lot of times in math there's multiple ways to solve a problem. So the formal way to solve this would be there's 6 people, order matters, I'm giving out 4 positions. 6, permutation, 4. I'm using a permutation and not a combination because the order matters. Another way to solve this problem would be to do the factorial. 6 factorial over, how many people do I not care about? Well, 2 people are not going to get the job. That's the formula way. 6 factorial over 6 minus 4 factorial. And then you can do what I call the common sense way. There's 4 positions. For president, I have 6 choices. Once I choose a president, I only have 5 choices left, then 4, then 3. So there's really 3 different ways to do this. Now, what I haven't shown you yet, but you probably already saw it when you looked for factorial, is that this is actually in your calculator. So if we did not want to do that by hand, we could go to our calculator. We could type in 6. Then we could go to math, go left, and choose 2, and then put a 4 there. And so our calculator can do permutations and combinations without, or for us, sorry. So first you put the number of choices, and then you put how many you're picking. So the total, and then how many you're picking. So you have to start with a number. You can't start with the NPR, which is a radio station I listen to every day on my way to school. Okay, anyways, ready? Next one. Oh, the answer was 360, by the way. What number do you use if you do it by hand? This is the by hand way. This is this plugged into the formula. That's the by hand way. Use the factorial button. 6 factorial divided by 2 factorial. You use a slide rule. How many ways can a 2-digit number be formed by using only the digits 5 through 9 and by each digit being used only once? The P stands for permutation. Right, it just stands for it. This one's not so bad because it's just a 2-digit number. Let's do it what I call the common sense way first, and then we'll do the other ways as well. So it's a 2-digit number, but I can only use the digits 5 through 9. So how many is that? 5, 6, 7, 8, 9. So there's 5 choices. Each digit can be used only once. So 5 choices for slot number 1, and then 4 choices for slot number 2. And you simply multiply them. What would this look like if you're doing a formula? Is this a permutation or a combination? Well, is 54 the same number as 45? It's not the same number. 54 is not the same as 45. Therefore, it's a permutation. So, it's a permutation. There are 5 choices, and I am choosing 2 numbers. So there is the setup, that's the formula, and if we wanted to do the formula by hand, we would do 5 factorial over 5 minus 2 factorial. 5 factorial over 5 minus 2 factorial. So 3 different ways. Do you have to do it all 3 ways every time? Absolutely not. I'm just showing you all the ways so that you can choose which one you like. We'll do some combinations. We will. Don't worry. The swim team has 8 swimmers. 2 swimmers will be selected to swim in the first heat. How many ways can the swimmers be selected? Remember, first question you always ask yourself, permutation or combination? So if I choose Johan, Chloe, I'm like, okay, you 2 are swimming in the first heat. Is that any different from me saying, Chloe, Johan, you 2 are swimming in the first heat? Does it matter whose name I call first? It doesn't matter because those are the ones chosen to swim in the first heat. Now, if they had lane positions, that might be a different story, but the problem didn't mention anything about the lanes mattering. So the order does not matter. So this would be 8, combination, 2. And from now on, you can just go straight to your calculator. You don't have to do it all 3 ways. So 8 math over 3, 2. Calculator tells us there are 28 ways that coach can pick those swimmers. If you want to do it by hand, totally do it by hand. Katie's going to adopt kittens from a litter of 11. How many ways can she choose 3 kittens to take home with her? Oh, look at those 3 kittens. She's going to take them home in that little basket. Permutation or combination? Yeah. Those kitties are going home with her. Does it matter which order she puts them in the basket? Nope. Those 3 are leaving with her. So order does not matter. So it's 11, combination, 3. Can I move on? They look like Boots from Puss in Boots. She's going to pay for them. Awards are given out at a costume party. How many ways can most creative, silliest, and best costume be awarded to 8 contestants if no one gets more than 1 award? Order matters or order doesn't matter? Order matters because you're giving them titles. Let's use some new people that I haven't called them. Adriel getting most creative and Alton getting silliest is different from Alton getting most creative and Adriel getting silliest. That's different, so the order matters. There's 8 contestants. The order matters, and there's 3 awards. Stuff is easy, huh? You just have to choose permutation or combination. We're not even finishing these off because I know you know how to press buttons in your calculator. Only 8 people showed up. No, I guess only 8 people made the finals. I don't know. We're trying to not make the answers be too big. All right, so you do have homework tonight. It's over permutations and combinations, and I will show you the answers tomorrow.